Hi everyone. So, progressive web app as a new cyber attack vector. So loud title, yeah? But the topic itself is pretty hyped these days, especially starting from the last months. But first of all, I would like to say that I want to encourage somebody to not use progressive web application, but restrict about responsibility and thinking about end users and provide some kind of dialogue between browser vendors and developers. So first of all, I want to introduce myself. My name is Vitalii Bobrov. I'm living in Poland, but originally I'm Ukrainian. I live in Poland just for the last 2 years. I really love to experiment with new features, and my latest, let's say, love is Houdini project. I have some experience with this, and it's pretty awesome. Also, if you will have any questions, feel free to ask me on Twitter or here offline, and you can visit my personal blog. So, what is the progressive web app? What is the thing that we call? Is it just a new buzzword? And actually, according to latest MDN definition, progressive web app is the modern web APIs that allows us to use UX enhancement to make our web application feel like native one. And of course, we're using progressive enhancement strategy to not break unsupported browsers and devices. So what features we can use to make our web app feels like native app? So first of all, we have offline capabilities. We can send push notification, provide background synchronization of our content, and use geolocation and other APIs to make our application feel like native. And the main core API that stands behind the progressive web apps is the service worker. It's actually the heart and the brain of our progressive web app. And with service worker, we got this pretty strange situation when, first of all, browser, actually Chrome, implemented this feature in their browser, and then we created standard to this implementation. And I think that it's actually a big issue from this side, because we skipped whole discussions with community. They haven't really gathered feedback before they release this feature. So what is service worker actually is, how it performs. So service worker is just event-driven worker, but that could be specified like proxy middleware that intercepts all requests between browser and network. And it can do a lot of magic itself. And user will never know what is going behind the scenes. Where it is available now. So from the last months, we got the pretty awesome situation when all major browsers already implemented at least basic support for service workers. So it's available, of course, on Chrome, Firefox, Safari, each released last month, and Microsoft did it even more. They allow progressive web apps to be found and installed through their Windows Store. So they some kind of first-class citizen inside Windows platform already. On mobile platforms, on iOS, they just experimenting with this and starting their implementation. So it's not really stable and usable for now. But this movement from the Apple side is pretty nice to have this. And in Android, when you install your progressive web app, it looks like any other application in your launcher. You can see the icon, the name of application, launch it like any other app. Actually, if you try to use, for example, Twitter Lite, PWA, and compare it to native application installed from Play Market, you will not feel any difference between them. They actually feels like the same application. So what possible to do with Service Workers for now? First of all, Service Worker is such thing that lives separated from browser. It executes in separate thread with separate context called Service Worker context. So it's limited to use mostly only asynchronous APIs, so you can't use some DOM APIs that are synchronous and so on. And it's event driven, so browser want to keep Service Worker alive all the time, the whole time. I mean, and that is why after some event, it wakes up Service Worker, it does its jobs, and then it sleeps again. So also we have this access to network, we have access to storage, and so on, so on, so on. So it is really, really powerful features that we have in our hands. And as any power, we should use it the right way. The purpose for Service Worker, first of all, to improve user experience, but not do some tricky things behind the scenes. But browser vendors, in my opinion, should also thinking about more limiting the time of workers, limiting the rules to apply to them, and so on, so on, so on. And I want to show why. For now, we have such security requirements for any progressive web app to have ability to install our Service Worker. First of all, it should be served from HTTPS. So it's not really huge requirement. Everybody can buy the certificate for their website. Even you can use GitHub and they provide you certificate for your subdomain on GitHub. So it's not really a big issue for everybody. It should be served from the same origin because for a script that installs Service Worker should be served from the same origin, and it's a really good limitation, but I'll show how we can go through this. So as I said, it executes in separate context and it terminates after its job done. So let's look how it's look like, this life cycle of Service Worker. So first time user come to our web application, there is no Service Worker, everything clear, and in our script we trying to define if Service Worker available and register our Service Worker, installing it. If something going wrong, we just got the error, and at this point our story is end. But if installation process was successful, we have active state. We can perform some requests to cache data, put it in cache storage, and so on, so on. After that job done, our Service Worker sleeping until we have some events like fetch request, like messages, like push notification or something. And on each of these events, it performs their job and sleeps again. So pretty simple life cycle. And first thing that I want to focus is installation process itself, because it's hidden from the user. User have no idea what is Service Worker and that this thing installed without any request from user side. Of course, I understand that to ask user directly, do you want to install Service Worker, is really stupid idea. Yeah. But anyway, we need to find some way. Even we need to have some kill switch for all Service Workers in browsers. For now, it's missed. So the registration process is straightforward. and looks like this. You call a navigator, service worker, register, pass to your service worker script, and then it returns a promise. Success one and error one. So nothing special there. And after a few visits of such websites, I inspected my application tab on Chrome. It just cleaned up one. I cleared them, then just used browser for 1 hour or so. And I have a bunch of service workers registered for me from Google Drive, Gmail, Google Maps, whatever. It was much more. And you can see them in Chrome DevTools on the application tab, and you can open show service workers from other origins. Another way to inspect the service worker is the inspect service workers tab. So here you can see the current service worker, you can see the process, inspect it, and so on. Also, we have in Chrome service worker internals that also allows to view the activated service workers, their status, and so on. But for just non-developer user, it's not clear, it's hidden. Nobody will search for such things. To unregister service worker, we have few ways. For example, we can go through all registration of our service worker and unregister each of them. On the other hand, we can unregister service worker inside our service worker script with :self-registration and register. And usually we're doing this when we are upgrading our service worker, because browsers has one day cache state for each service worker before they invalidate it. And there are a lot of workarounds regarding how to upgrade service worker, and they trying to change specification in this case. Also, we need to unregister some service workers if they was registered not by us, but by somebody. So we can, for example, register service worker by link. The main issue here is XSS, cross-site scripting, that somebody allowed to execute some scripts on your website. But with service worker power, it could be persistent. It could live for a long time in your browser, nobody knows about it, and it could be executed when browser is switched off. So with help of JSON-P, we can register our third-party service worker from other origin. So actually JSON-P is kind of created script for us, and it executes callback. It doesn't provide any HSHR request, AJAX calls, and it creates inline scripts. That is why it not broken the same origin policy. And they need to execute some callback in global scope. So this makes, as I said, attack persistent for a long time. Below you can find links with more deeper explanation how to use JSON-P for that. And here's the example of this attack. This is the power of URL. Is it readable? Everybody can read it, yeah? So I formatted it for you. Actually, this link will create script tag and trying to register service worker, and the link to this service worker provided as JSON-P callback. And inside this callback, we created functions that listens for fetch events and intercepts our fetch request. And we can see in console log if our service worker was registered for us. So regarding all these security restrictions, certificates, same origin, it could be somehow omitted. It's just the one case how to do it. So even if your application not progressive web app, somebody can register service worker for you and do some stuff. Now there's a big seen in service worker HTTP request interception. It controls whole fetch request from your page. Here is the example demo that shows fetch request cached by service worker. So it just registers the service worker, return our service worker object in console, and then after the next visit of this website, we can see each fetch request with every details. And it not corresponds only to the request to the same origin, but any request. So it's a big field to deal with. For example, I was wondering, but Chrome, when loading extensions, it used internal Chrome protocol, and it also goes through the service worker. So actually we can kill every extension in browser. To do this, we just add an event listener for fetch requests, filtering requests to Chrome extensions, and just return error response instead of the actual script. Just imagine you have some ad blocker installed in your Chrome, and you visiting some website, it has a lot of advertisements, pop-ups, all this stuff, and they just kill your ad blocker. And nothing stops them. Also, we can modify requests, uploads, downloads. So you can, for example, upload some invoice, and service worker can read it, modify, and return the data that not uploaded by you. And we can do it even more with WebAssembly power. There is a way to use WebAssembly module inside your service worker. It could be look like this. So you load in some parser for PDF, for example, from WebAssembly, modifying it and returning updated PDF instead. Here's a link to the in-browser WebP decoder made with WebAssembly and going through the service worker. It does pretty same thing, but for WebP images. Also, we can use resources of your laptops and smartphones for performing some computation, or use your cache storage to create some kind of peer-to-peer torrent network or something. So let's imagine you user visits some Kitty Hub. It's the famous website with Kitty's videos, hottest one. So, and they want to monetize their website. So they could use some cryptocurrency mining right in browser. So this is the website of CoinHive, the most, I think, famous library for mining inside browser and Node.js. You can try the miner right in their website. They have play button, and what it does, it heats up your CPU. I have 4 cores on my MacBook, so that is why it's showing 300%. So it's using actually 3 cores of my CPU to mine some cryptocurrency. And the usage of this library is just few lines of code. You importing the script, creating the instance of your miner, providing your website key, and just starting your miner. You can just log some states of this miner and so on, so on, so on. So it's pretty easy, but user might not spend a lot of time on Kitty Hub. So monetization won't be so big, but we can execute our miner when browser is switched off. And to do this, we need to wake up our service worker. We have few APIs that could do wake up for our service worker. It's background synchronization, push notifications, and messages from other workers. On each of these events, browser will wake up service worker, hey guy, you need to perform some job, and that's it. So let's imagine that we have push notification event. It comes, we have some, actually in Chrome at least, it is restricted to show something on push notification event. It won't to execute the code if you don't show actually a notification. But we can show something, hey, you got the new hot kitty video. And at the same time, we could start our miner instance to work again. Actually, here we're starting it and never stopping. But browser anyway will terminate service worker of the time. But it could be good enough to mine some coins or something. And if your resource has a big amount of visitors per day. So with just these small commitments, you can achieve something at least. So you can perform a lot of jobs inside these callbacks and ask browser to wait until you finish. It could be everything you want. So these are all highlights that I have for now. And I again want to say that I want you to not create PWA, but think about end users and be restricted about security of your applications to, again, protect your end users. So try to find some issues and report them to vendor browsers and so on. Thank you.